Hi guys, Buildzoid here, and we're back with the 5700X3D. This time we're going to be taking a look at some memory overclocking with it. So yeah, let's get into it, starting off with the system specs. The CPU is, of course, the 5700X3D that I purchased, so big thank you to the channel supporters for funding that. Then the motherboard is a Gigabyte B550 Vision D-P, which was generously purchased for me by a fan of the channel a few years ago. So yeah, that board isn't from Gigabyte for once. And then the memory kit is an Asgard Loki DDR4 2x16 3600 CL14 1.45 volt memory kit, which was provided by Asgard. So big thank you to them for sending over the memory kit. And that is just dual rank Samsung B die, which you can pretty easily tell from the 3600 CL14 TRCD15 at 1.45 volts XMP settings. So yeah, pretty standard high-end dual rank Samsung 8 gigabit B die bin. So yeah, that's the parts that I'm running here. Now then, in terms of the setup, you can see that I have a fan on the memory sticks because dual rank Samsung B die runs quite hot, so you want a fan on it. Also, it is temperature sensitive, so you'll get better results out of it if you throw a fan on it. Because if you don't run a fan, you just end up basically stuck with worse settings in terms of what's actually stable. If you're wondering why the motherboard is orange, I ran this motherboard on LN2 in the past, so that's just the insulation on there. Um, and yeah, that's kind of that, I guess. Like, yeah, there's fan on the memory, which is basically the main thing here. So anyway, let's take a look at the results. Now, this took a lot longer to set up than I wanted it to. I was like, the original idea was like, oh, I'll just it'll take 24 hours, right? I'll just punch in some basic settings. 1 or 2 days, I'll have like a video ready to go. And yeah, so that didn't happen. But as you can see, so I guess I'll just show you what did. Yeah, so here's the first configuration I tried. And sort of the main reason I decided to even do this is that I really wanted to see how this would behave with a BCLK overclock with the 5700X3D, because I was wondering, like, is there any like weirdness that you run into with memory overclocking or like FCLK if you're running BCLK that's higher than 100? Because like I've messed with that in the past, but I've never actually like bothered to go for like a full stability um, validation with any kind of BCLK overclock in the past. So yeah, anyway, so the BCLK is at 103, um, which is basically as high as you can like this is as high as you can go on the CPU that it actually like consistently still improves performance. Um, so yeah, also I should point out if you have like an X570 motherboard, setting the BCLK to 103 will probably make the chipset not work. Yeah, there's a reason I'm using a B550 board for this. Um, and that is that in my experience, the X570 chipset really doesn't like BCLK overclocks for some reason, whereas like B550, A520, X470, X370, B450, B350, all of those chipsets will tolerate actually very high BCLKs, and then there's X570, which just kind of doesn't. Um, so that's like the obvious weirdness that you run into with BCLK overclocks, but I was more wondering, like, is there any strangeness with the FCLK or the memory itself? And there is some strangeness, but we'll get to that later. Anyway, so originally I was like, oh, this will be, like, other than maybe the BCLK causing some weirdness, this should be really a quick and simple memory overclock, right? This shouldn't take that long. So anyway, here's the first iteration. 3 errors in 8 hours. So yeah, basically I started Karhu, went to bed, and woke up, and 3 errors. Okay, so that's great. Oh well. Then I was like, okay, I'll check that like it's not a memory controller issue. So I ran linpack, ycruncher. Those both passed. And then another error in 9 hours. Also, there was like other configurations in between these runs that weren't succeeding. So yeah, this was very very fun. Um, and then finally, and this is the error that sort of made me decide to just kind of give up on, especially TRCD4, like basically just made me give up on running like tight primaries because that's like been my experience with sort of dual rank BDI on Ryzen in general is that like you try to run low TRCD or well, usually any of those like late error like errors that show up really late, probably a primary issue. Because a lot of the other timings they just break very cleanly. Like it's so low that it basically won't even post a lot of the time. Um, and so yeah, so at this point, 14 hours, one error, and it was like, okay, this is getting kind of stupid. So I just kind of gave up on TRCD 14 and TRP 13 and ended up with the settings that we have here, right? 14, 15, 14, which, yeah, I was, kind of hoping for something a bit more impressive than that because this is pretty, like, these are very generic BDI settings, but oh well, if the RAM doesn't want to do it, there's not really anything I can do about it. So anyway, ran Karhu for 14 hours. Now, technically, if you get an error, after 14 hours, right? So if you get this situation, very technically, if you wanted to prove that you're not going to get this error again, you'd probably want to run at least 28 hours, right? Because if you're getting like one error every 14 hours, then to prove that that error is no longer going to happen, you would need to run at least 2 times 14 hours, which would be 28 hours. But I want to get this video done at some point. So I didn't do that. And I'm not going to do that because honestly, like, as far as I know, a lot of people don't even stress test their, like, 14 hours is already a ridiculously long runtime for a memory stress test by compared to what I've seen a lot of people do on the internet. So, yeah, but I will point out that, like, look, if you are, if you have a system where stability is absolutely critical, then, in this kind of scenario where it's like, oh yeah, my previous settings had one error in 14 hours, you should probably run like a 24-hour stress test at that point, just to make sure that it's like you didn't like the error, like because the concern is that the error didn't show up because you stopped the test before the error could show up again. So yeah, anyway, I'm not doing that though. I wanted, like, this took 5 days to set up, or yeah, basically like 5 days or something, because I have 3 screenshots of like the really, like a few examples of like the errors that showed up, but those were not the only failed attempts. There was a lot more than that. So anyway, 14 hours of Karhu, which, is mostly just for me to go like, definite, like, technically, like I just explained, right? Like technically, you'd probably want to run like 28 hours, but for me, it's just a case of like, well, previously there was an error at 14 hours, now there isn't, and I'll just take that in that case because I'm not running a memory stress test for 2 days. Like I want this video over with at some point. Anyway, I also ran Y-Cruncher VT3, right, and so that ran for over an hour, well over an hour. You can see like 6,800 seconds over there. And I also ran over an hour of LinPack, so this is 50 loops and 90 seconds per loop, so that's like 4,500 seconds. And this is mainly to verify like the Infinity Fabric stability and the memory controller stability. And of course, I had hardware info running the entire time, and there's no errors, so yeah, because that is something to watch out for with Ryzen, is if you're pushing the Infinity Fabric, you can get errors down here. Though usually that's an issue if you go past 1900. And we're not above 1900 with this setup, so yeah, it's not too surprising that there aren't any errors, but you still want to watch out for that, right? So yeah, so that's all of the stability tests run on this, and they all passed. So at this point, I'm just going to commit to this video take, and let's go take a look in the BIOS to see the settings. Oh, and now I don't know which capture. Wait. This one. There. So we can see the post code. So here we are in the BIOS. As you can see, 103 BCLK, and let's just talk about the weirdness that the BCLK actually causes. Because it does cause some weirdness, and the main weirdness that it causes is that FCLKs approaching 1900 don't post, which is really weird. So this CPU with like 100 BCLK, and I'm just going to pull up the calculator. So, which I failed at somehow. There. So with 100 BCLK, this CPU does work at 1900 FCLK. I didn't actually like fully stress test it at 1900, but it does boot and you can like run benchmarks and stuff. I'm not sure if it doesn't produce errors, but it does run. Now 19 times 103, that doesn't work. That will just straight up not post, which is really weird. 1866 at 103, so the 1866 ratio, yeah, that also doesn't post, even though it's like 1921. And 1833 is what I'm using right now, and that does work because that is below 1900, right? That's 1887, so that does work. But interestingly enough, 1933 at 103 BCLK, that actually does work. That does post. It's very unstable at that point, but it does boot. So that's really interesting that basically there's like a hole in the FCLK if you have a BCLK overclock. Because it's not like that doesn't happen without the BCLK overclock. Like at 100 megahertz, 1900 FCLK posts, 1866 posts. But with 103 BCLK, 1866 doesn't work. 1900 doesn't work. And I think even at like 101 or 102 megahertz BCLK, that still actually ends up being an issue. Because, yeah, like I was running into some real weirdness, like getting the system to post when I was first setting this up. And I think that's almost entirely related to just like the FCLK doesn't like running close to 1900. My theory is that there's some kind of like change in the boot up procedure between the FCLK ratios that are 19 or lower, and then the FCLK ratios that are 19 or like 19.33 and higher, because 1933 doesn't have any issues with high BCLK whatsoever. I mean, other than the fact that it's unstable, but it's also unstable at 100 megahertz, so that's not the BCLK overclock's like that's not a fault of the BCLK overclock. The CPU just can't do over 1900 FCLK, which is pretty typical. In fact, this CPU's Infinity Fabric clocks even worse than my 5950X does, because my 5950X is actually like you can run a lot, like, yeah, you can run quite a lot of benchmarks all the way up to like 2033 Infinity Fabric. It's not stable, but like for benchmarking, it is viable all the way up to like 2033. Whereas this CPU actually starts significantly dropping it off in performance, even with very high VDD VDD 18, which is sort of a like raising VDD 18 can help with Infinity Fabric stability a bit, though. I don't have any CPU where raising VDD 18 like completely eliminated Infinity Fabric instability, but it like can do that. So, like I've heard other people have success with that. It's just like neither my 5950X nor this 5700X3D shows that. Like yes, the stability gets better, as in like scores go up in benchmarks, but it never fixes the instability. Because the thing when you have the Infinity Fabric on Ryzen 5000 clocked too high, and it's spitting out errors, is it actually does error correction, so your performance drops off. Like it doesn't outright cause system crashes. If like you first notice a performance drop, and then eventually you might even get to the point of it like being so unstable that it causes crashing. But anyway, so basically this CPU can't do more than 1900 FCLK, which is pretty typical in my experience. And also with the BCLK overclock, FCLK is approaching 1900. Like anything above 1900 just straight up won't post with the FCLK ratios that are below 19.33, right? So basically like 1867 over here, that wouldn't post. 1900 wouldn't post. This does, which is a bit weird, but yeah. I think that's just down to like AMD having like a different boot up procedure for FCLKs above 1900, or like the FCLK ratios above 1900. Because technically, with a BCLK overclock, you can get your FCLK above 1900 without using the 19x ratio, but you get the idea. Anyway, the memory multiplier is at 3666 because that synchronizes with 1833 on the FCLK. UCLK div 1 mode is obviously UCLK equals MCLK, so the memory controller and the memory and the Infinity Fabric are all synchronized. And then in terms of voltages, SoC voltages at just 1.148, which in my experience is sort of it's a nice, safe SoC voltage. Seems to work best for me on a lot of CPUs. Though you can often get away with less, and in a few rare cases you might need more. Though in my experience, usually around 1.15 tends to work optimally. Admittedly, that's on a sample size of technically I'm counting all of the Ryzen 3000 series CPUs in that. Those also tend to sweet spot around 1.15 for me, so um, yeah, anyway, so that's that. VDD18 is bumped to 1.92 volts. This is perfectly safe. And in fact, a lot of motherboards will actually do this for you on auto. Um, and this can help with just FCLK stability, but also sometimes with core clock a bit. Though that's not really a concern because this CPU out of the box just runs a ton of vCore. So the 103 megahertz BCLK really doesn't have any negative side effects in terms of CPU stability, because like the safety margin that AMD is shipping the CPU with out of the box is just absolutely massive. Um, anyway, then these voltages aren't relevant to memory overclocking, so I've just left them on auto. DRAM voltage is at 1.5 volts. Technically, if I really wanted to push the primary timings lower, you could try like 1.6 or higher. Though in some scenarios, you might find that actually pushing the memory voltage too high causes instability, and it just makes your life more difficult. Um, so yeah, for convenience, I just like to stick to 1.5 volts. DRAM termination is on auto because it just wasn't necessary to adjust it with just 1.5 volts on the memory. If I was pushing to 1.6 volts, I would probably start messing with the DRAM. I would potentially start messing with the DRAM termination. Though it really depends on the memory kit as to how important it is to be able, how important adjusting that is. VDDP at 900. Um, I didn't really test a whole range of VDDP voltages, but this works, so I'm just gonna go with it. And then VDD also, it's like a perfectly safe value. Like it's not high enough to really be concerning in any way, so I don't really see any point in trying to minimize it or do anything. This voltage does vary by motherboard a lot in my experience. Like some motherboards like it pretty high, some motherboards prefer it low. Also, it varies by AGSA version, so um, yeah, that's Ryzen memory controller things. And then VDDG at 1050, which is kind of on the higher side, but in my experience, it can sometimes help with Infinity Fabric stability. Um, and then for CPU VRM settings, those are on auto because, well, the CPU doesn't, the core. There's plenty of core voltage, so we don't have to mess with that. And the SoC load line calibration it's not necessary to adjust that. In my experience, so I didn't. So that's the voltages. Oh, I guess I should have pointed out that I am on the F16G BIOS version. Whoops, don't want to escape just yet. And now let's take a look at the timings. So I do have power down disabled, as there's no reason not to disable it on AM4. And then for memory timings, 14, 15, 8, 14. Yeah, so pretty standard, pretty standard dual rank BDI timings for 3800-ish. We're technically slightly below 3800, but that's why I said 3800-ish. Anyway, TRAS at 26, which TRP and TRAS, I'm on a lot of kits you can get away with 13, and then there are some memory kits which are really, really good, and those might be able to do something crazy like, say, this. This kit is not doing that, as I think you could tell from the screenshots I had where there was an error showing up after 8+ hours with TRCD14. So yeah, but I think TRP and TRAS might not be minimized in the current configuration. But yeah, at this point, I'm just done with this. And TRP 13, it's pretty unlikely that 12 would actually work. And TRP 13 is not going to be that much faster than 14 anyway. So I'm not too worried about that. And then TRAS is at 26 just to match it to the TRC, right? Because I like to stick to that rule of TRC is equal to TRP plus TRAS. That rule isn't set in stone, but at the very least, it generally doesn't give you anything unstable. So, yeah, I like to use it just because it makes things a bit simpler than trying to minimize every single timing individually, especially in certain scenarios that won't even do anything. Like, um, the issue is this seems to vary by like BIOS version, but I have done tests in the past with memory sticks that like can't do low TRC, where I'd like intentionally set the TRAS really low and it would work. Or I would intentionally set the TRC really low, but the TRAS really high, and it would work. And if you set both of them really low, then of course it didn't work because those memory sticks can't do low TRC. So yeah, I just like to stick to that sort of like TRC is equal to TRAS plus TRP rule. As it makes things a bit simpler. Though I think there's probably room for the TRC to be a bit lower. Like I'd be kind of, oh, at this point I'm not gonna, like this took already way too long, so I'm not gonna investigate. But I would assume most good B-die kits can do like a TRC of 38, maybe lower. So 40 is a touch high, and obviously if I was going for 38, then I would be running it with TRAS 24, right? And the minimum possible would be like a TRAS of 21 with a TRC of 35. But 35 TRC I am not actually sure would work, because that is very low. So anyway, yeah, so I ended up testing TRAS 26 with TRC 40, which is still really good. Like for comparison, most other DDR4 memory ICs can't do TRCs much below like 60. So this is like the low TRC is one of the like core advantages of dual like Samsung B-die over other DDR4 memory chips. Anyway, TWR at 10, because that is literally the register limit, so you can't set it lower than that. TCWL at 14, because, did I do that? Oh yeah, because I have TRDWR at 8. So, yeah, I didn't test 12, but, like, it doesn't really, like, cast write latency isn't really that important, so... like the easy way to set it is to just kind of either keep it equal to cast latency or 2 down. The thing is, you might like, it's been a long time since I've messed with this, but I'm pretty sure that you can trade read to write like this timing for cast latency. However, I'm pretty sure this timing actually takes priority from a performance perspective. The thing is, like, anytime you're like small, like individual, like one individual timing on its own generally doesn't do very much, which is why I have this sort of like, especially when it comes to like memory overclocks that I actually end up stress testing. I have a very sort of loose approach to a lot of the timings where I don't try to minimize each individual timing, because 1 or 2 ticks of basically anything is just not going to make that much of a difference. So yeah, like obviously adjusting all of your timings from an XMP profile down to like something that looks like this is going to increase your performance quite significantly. But then like spending hours and hours stress testing like one timing adjustment is kind of a waste of time, because it's not really going to, like, you're not going to gain that much performance for the amount of time that you're going to put into, adjusting one individual timing. So yeah, but I'm pretty sure off the top of my head that like TRDWR and TCWL actually have a relationship where you can have one of them, like by lowering one of them you have to like, or by raising one of them you can lower the other one. Because I guess when you're transitioning from a read to a write, I'm not sure how TRDWR is implemented on AMD CPUs. I'm assuming it's from the end of the... Wait, is it? It's probably from the end of the read burst. I'm not sure. Anyway. So, yeah. But cast write latency at 14. Like, right. Also, it's worth noting that the write timings generally aren't that important from a performance perspective. Anyway, now on to timings that actually matter. TRRDS, TRRDL, both at 4, because that is the register limit for them. You can't set them any lower than that. WTRS at 4, WTRL at 8. These actually could probably go lower, though it varies by memory kit quite a bit. I think the lowest I've seen is like a 2.6 or something. I generally stick to just 4.8 because a lot of the time, like 4.8 works always, basically. At least with like with the Samsung B die, it works basically always. Um, and I don't, like I mentioned earlier, one or two ticks of any one timing just isn't worth the effort, in my opinion. Then we get TRFC, which I just have at 288. A lot of the time, something like 266. Wait, that's not 266, that's 255. But a lot of the time, 255 might also work if your like memory is running cool enough. Or if you're running enough voltage. Though that actually depends quite heavily on the memory sticks. And B-die especially can have like a really bizarre amount of variance from kit to kit in terms of the TRFC limits. Because there are like B-die kits out there where you can't set the TRFC below like 300 or even like 330. And then there are other kits that can run it at very, very low values like 244 or something. Or even like 222, depending on the voltage. And frequency. Um, so yeah, but I like to stick to 288 because on most B-die kits that does tend to work. Though there are some rare exceptions where you need it over 300, which is really quite unfortunate, but you don't tend to find those kinds of, like, that tends to happen when you buy like a 3200 CL16 B-die kit, not, a 3600 CL14. RTP at 8, might do 6. Actually, what's the register limit? 5. Yeah, it might have been worth trying 6, but like I wanted to just get this video over with at this point, so yeah. TFAW 16, that's actually, I don't think that's the register limit, but setting it any lower than 16 is actually just not going to do anything because the TRRDs are at 4. Read to write at 8. I didn't test lower values for that one, so it might go lower. I don't know. Read to read, same dim at 4, different dim at 4. These are your dual rank timings, and these don't actually go any lower than this, interestingly enough. TRD SCL is at 2. Write to read at 2. I didn't test if 1 would work, and then we have the write to write dual rank timings, which are at 6.6. I think 5.5 actually might post, but I didn't look into stress testing that. And then SCL is at 2. So yeah, then TCKE at 1, Proc ODT at 40, which Proc ODT is heavily dependent on what motherboard you're using. This board, and actually, in fact, in my experience, most Gigabyte boards, at least the ones with the 6-layer later revision daisy chain topology, they favor 40 ohm Proc ODT. Like that's the optimal Proc ODT, basically regardless of what you're trying to do. There are other motherboards where you'll actually find that the Proc ODT changes based on like what voltages or memory sticks you're running, whereas in my experience with like say the Vision here, or I also had a B550 Pro AX motherboard. Yeah, both of those boards, you just set it to 40, and that's the optimal Proc ODT for doing like 4800 on B-die or 5000 on Micron or like whatever. It just, yeah. So these Gigabyte boards basically seem to be tuned for like 40 ohm, whereas for comparison, like I have an ASRock board where I think the optimal value is like 34, and it kind of changes based on what exact settings I'm running with that one. Anyway, command rate and gear down mode are on auto, because disabling gear down mode and running 2T actually doesn't do anything, like performance-wise is basically a wash, and 1T can be very difficult to stabilize, and as you can probably tell, I don't, like I've mentioned before, I don't want to spend any more time on this. This was supposed to be a quick memory overclock, and then it took 5 days. And mostly because I was trying to get TRCD to like trying to push the primaries too low, but yeah, I don't need any more complications at this point. And then everything else is just on auto, because at least in my experience, the Gigabyte boards tend to do a pretty good job of setting these settings themselves, so not really any reason to try to adjust them manually. Though if I was like, let's say if I was trying to run disabled gear down mode 1T, then actually fiddling with the CAD bus setup timing and drive strengths and such would actually probably be a requirement. Um, so yeah, in order to get like 1T command rate without gear down mode fully stable. So anyway, so that's the settings, and I don't think there's anything. Oh yeah, the last thing I did is just disable TSME over here. Most boards will actually disable that for you on auto because all it does is like make your memory performance worse for like there's some I think it's some security feature, but unless you're running like a server, I don't really see any point in having that enabled, and it does harm memory performance quite a bit. So, yeah, that's it. That's the memory overclocking on the 5700X3D with the Vision. And like I was really hoping that this CPU would do more FCLK. Because yeah, like I have a 59, like the 5950X I have doesn't go over 1900 FCLK, and so I was kind of hoping that I'd get lucky and finally get get a Ryzen 5000 series that goes over 1900, but well, it doesn't. Which I'm not particularly surprised by that, but yeah, I was kind of hoping to have a chip where the FCLK would go a bit higher. That would have made things a bit more interesting. Um, but yeah, overall, this is just like pretty standard B-die settings in the end. Yeah, and the BCLK overclock really didn't. I mean, the only real weirdness it introduced is that like FCLK's approaching 90, like, well, FCLK's like it broke the 1866 ratio and the 19 ratio for the FCLK. So that's sort of the only weirdness that the BCLK created for me. Though I should point out, I don't use M.2 SSDs on the test benches, and I have heard that M.2 SSDs can get quite weird about BCLK overclocks, but I don't have any experience with that myself. So, um, yeah, obviously, if you wanted to like adapt these settings to like run on say an X570 board, or you just don't want to deal with any potential weirdness of a BCLK overclock, you could just set the BCLK to 100 and then just set this to 3733, and that should like that I, that should work, right? Honestly, even like 1900 would probably work, but I haven't actually stress tested that, and that is a higher clock than what I'm running here, right? Because 1833 times 103 is not 3800. It's like 37.7. Like it's not quite up there yet. So yeah. So if you wanted to use like adapt these settings to like a X570 board, or you just don't want the BCLK, then you just drop it to 3730, like 3733 and 1866, and that should work just fine. And yeah, so that's it. Man, I do not miss trying to stabilize dual rank B die. I'd forgotten how fiddly it can be. So yeah, hopefully you found this interesting, if not particularly useful, and that's it for the video. So thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the HOC Teespring store where you can pick up shirts, hoodies, posters, the usual YouTuber merch. And I've also got a Bandcamp. There's links to all of that down in the description. If you'd check them out, that would be much appreciated. And that's it for the video, so thank you for watching, and goodbye.